Lesson 7.10 is implicit differentiation at a point level 2. Sometimes we have one tangent line, sometimes we have two. So the first two examples, we're just going to have one. It says if negative x squared y equals negative 3x cubed minus 2y, find the equations of all tangent lines to the curve when x equals 1. So delta math won't tell you if there's one or two. You're going to find that out while you're doing the work. So my whole goal here is to get this function solved for dy over dx. So my first job is to take it and differentiate it, or get the slope of this implicit function. We said implicit just means there's x's and y showing up in the whole formula. So I'm going to take the whole thing times a d, or differentiate it with terms of x. Okay, so remember we've got product rule. And so I'm going to keep the negative x squared first. So negative x squared times the derivative of y would be simply 1, but because it's in relation to x, we got to have a y prime. Plus, this time I'm going to take the derivative of negative x squared, which would be negative 2x. And I'm just taking times a normal y. I don't have to take the derivative of y. So no, I would not need that plus sign there either. I could just have minus. Done with that side. Okay, this side's easier. We got power rule is negative 9x squared. This would be minus 2, but because I'm taking the derivative of y, I need y prime. So my goal here is to solve for y prime. So here's y prime, here's y prime. So I want to get those two terms on the same side. Doesn't matter how you do it. I'm just going to keep the negative x squared y prime here. So I'm going to add 2y prime over. I'm going to have to move this negative 2xy over by adding it, so now it's positive 2xy minus 9x squared. Now I'm going to factor that y prime out. And so that would leave me with times the negative x squared plus 2. And then I get to divide away negative x squared plus 2. Okay, so y prime, or the derivative of this function at any point, can be found by 2 times x times y minus 9 times x squared over negative times x squared plus 2. That's going to be important. But what we don't have right now is an x and a y. All they gave us is when x is 1. So I have to find y when x equals 1. And the way we do that is just plug it into the original function. Okay, so I'll have negative of 1 squared times y equals negative 3 times 1 cubed minus 2 times y. 1 squared is 1, but times a negative makes it negative 1y, or negative y. 1 cubed is 1 times negative 3 is negative 3 minus 2y. I'm going to add 2y. So that would be y equals negative 3. So my point is at 1 comma negative 3. That is now what I'm going to plug in to my slope right here. So I'm going to have 2 times my x of 1 times my y of negative 3 minus 9 times 1 squared over negative of 1 squared plus 2. 2 times 1 is 2, times negative 3 is negative 6. 1 squared is 1, times negative 9 is negative 9. 1 squared is 1, times the negative is negative 1 plus 2. Negative 15 over 1, which is negative 15. That's my slope at that point. Okay, but then the final thing it wants... Sorry, I don't have any other good colors. Oh, I have the green. Just kidding. Final thing it wants is the equation of the tangent line. So we want point slope form using this point and the negative 15 slope. So it'll go y minus negative 3. So y plus 3 equals negative 15 times x minus 1. A lot of work for that. The graph is just something I included. They had it on there, I guess is what it is. So at the end of each question, you'll see that. But basically this graph is this, and at the point when x was 1, we found that y was -3, and look how steep this line is. It has -15 slope, so that's the equation of that tangent line. Ooh, okay, let's try number 2. Number 2 is a funky graph. This isn't even a function because it doesn't pass the vertical line test. We're going to first differentiate the whole thing. Man, this pen doesn't work. All my pens are drying up. Okay, product rule again. I'm going to keep -x. And then I'm going to take the derivative of y squared, which is 2. I'm going to actually float the 2 in front. 2y, but then times the derivative of y, which is y prime. Plus, then I take the derivative of -x, which is -1, and keep the y squared. And then this would be 4y cubed, but times a y prime, equals derivative constant is gone. So my terms with y prime are here and here. And so all I really have to do is add this y squared to the other side. And then I'm going to factor out y prime. So that would leave me with -2xy plus 4y cubed. And so I know that y prime is really y squared all divided by -2xy plus 4y cubed. So that's how I calculate slope. Okay, but I'm going to have an x and a y to plug into this. They're telling me that y needs to be 1. And so I'm going to plug in to the original. It'd be -x times 1 squared plus 1 to the 4th needs to equal -1. 1 squared is 1. That would be -x plus 1, -1. I'm going to actually do some flip-flopping here. I'm going to add x to make it positive, and I'm going to add 1 to 1 to make it 2. So the point is at 2, 1. And you can actually see it. It's right there. But again, you won't have that graph. Okay, so now I need to plug that in to find the slope at that instant. So it'd be my y squared, which is 1, over -2 times 2 times 1 plus 4 times 1 cubed. That'd be 1 over 2 times -2 is -4 times 1 is -4 plus 4. Ooh. You might think, ooh, I made a mistake. No, you didn't. So 1 divided by 0, think about what that means as slope. We're rising 1, we're running nothing. We're rising, we're not running. We're rising, we're rising. Having a 0 in the bottom gives you undefined slope. And the only type of lines that have undefined slope are vertical lines. How you write the equation for a vertical line is it's x equals something because it goes through the x axis at that value. So all I have to do is write the equation that is the x value of my ordered pair. So this tangent line is actually just x equals 2. See it? So those are nice. You don't have to put them in point slope form. All right, and then there's one more in the back to show you what two tangent lines look like. First, we need to take the derivative of our function. With respect to x. So product rule again, that will give me x, so keep it, times derivative of y, so y prime, plus derivative of x is 1 times a normal y, plus 3y squared times a y prime, minus 2x, that goes away, and then that's still 0. I want to point something else out too. You could go ahead and figure out your ordered pair, plug it in for x and the normal y's, and just solve this for y prime. You might like that better. I can actually go ahead and show you what that looks like. I kind of do, but I kind of don't. I have mixed feelings about it. But anyways, let's figure out what x is when y is -1. So we'll have x times -1, so it'll be negative x, plus -1 cubed minus x squared plus 3 equals 0. -1 cubed is -1. Here's what has happened. I now have created a quadratic because x is squared, then there's an x, then there's a constant. So what I want to do is get this thing simplified where it's in standard form, which is ax squared plus bx plus c, and get it set equals x equal to 0. So I'm going to actually move this negative x squared to the right over here, so it's going to be positive. I never want this to be negative. I'm going to add x over, so now it's positive. This was a 3 minus 1. This was a positive 2 here, but I'm going to subtract it over, so now it's negative. This is my function that I have to factor. I need two numbers that multiply to make -2 that add to make 1. That should be positive 2 and -1. The solutions come from setting each factor equal to 0 and solving. So that one's just -2, and that one's just 1. So now you're seeing that I have two different points that are going to have tangent lines. So I've got at -2, -1, and 1, -1. So I'll just show you, like I said, what this looks like. So I'll do the first point, the -2, -1. This would be -2 y prime plus y is -1, plus 3 times y squared times y prime minus 2 times -2 equals 0. So simplify everything. We got -2y prime minus 1. -1 squares 1 times 3 is 3y prime. -2 times -2 is positive 4 equals 0. So now just combine like terms. So we're going to put -2y prime plus 3y prime together. That's y prime. We're going to put -1 plus 4 together, and that's positive 3. And then subtract the 3 over. So y prime equals -3. That is the slope at, can't spell, slope at -2, -1. So I have all the info I need right here to create an equation. Y minus -1 equals -3 times x minus -2. So there's answer number 1. So again, you can decide, do you want y prime solved for? The thing on this problem is we would have had y prime solved for, so x and y, you just had to plug them in. And you could have used it for both points. So now we'd have to do that again this way at 1, -1. And so I'll let you go ahead and do that and see if you get the same value as me. All right, the other slope I got was 3/4. So my final answer as the equation of the tangent line would be y plus 1 equals my slope of 3/4 times x minus 1. And again, this is a graph just to kind of help you here. We were trying to find out when y is -1. And in this graph, that happens here and here. So one line, tangent line, will have a positive slope, and that was our 3/4. Look, you can see that's going up 1, 2, 3, right? 1, 2, 3, 4. And then the other one was at this point, -2, -1, and we got a slope of down 1, 2, 3, right 1. So we can tell that we did it right.